This is question number 3 of the 2015 KCSE Paper 2. It says, an arc of 11 centimeters subtends an angle of 70 degrees at the center of a circle. Calculate the length correct to one decimal place of a chord that subtends an angle of 90 degrees at the center of the same circle. So I've drawn the same circle out twice. The first time that I've drawn it out, I've shown an arc. So this arc here, which is 11 centimeters long, which subtends an angle of 70 degrees at the center of the circle. And then next I've drawn out the same circle again, and I've shown a chord, this black line here, which is subtended by an angle of 90 degrees, a right angle, at the center of the circle. So how are we going to go about solving this question? Well, first we need to realize that this 11 centimeters is a proportion of the circumference of the whole circle. And we know that it is, and we know what fraction of the circumference of the circle it is. And the fraction of the circumference of the circle this 11 centimeters represents is 70 over 360. That's because a whole circle turn is 360 degrees, and we know that this 11 centimeters arc is subtended by an angle of 70 degrees. So it's 70 over 360 of the whole circle. So if we're going to represent the circumference of the circle as x, we can write an expression which would be this portion, 70 over 360 multiplied by x is equal to 11 centimeters, and then we can rearrange this to find x. Once we have found x, which is the circumference of the circle, we can work back using the formula that we've learned for the circumference c of a circle, which is c is equal to 2 pi r. We can rearrange this to find r, so that would be r is equal to the circumference divided by 2 pi. So we can rearrange that to find the radius. So once we find the radius, we know that the radius is this here and it's also this here. And then from that we simply use Pythagoras to find out the length of this chord here, since we have a right angle. So let's start with the first step, step 1, before we move on to the second step, step 2, and then the third step, step 3. Remember, the first step is just a rearranging of this formula to find x, the circumference. The second step is rearranging of the formula for the circumference of a circle to find the radius. And the third step is using Pythagoras to find the hypotenuse, which is the same as the chord that subtends the angle at 90 degrees. So let's start with step 1, which is to find the circumference of the circle. So the circumference x of the circle can be expressed using this equation here, 70 divided by 360 multiplied by the circumference, x, is equal to 11. We can rearrange this to make x a subject. So we get x is equal to 11. Let's bring this 360 to the other side by multiplying both sides by 360. 11 times by 360 divided by 70. And that's equal to x. As this is a paper where you're allowed your calculator, let's just simply put this into the calculator. When we do that, we get 56.571. I'm probably, instead of working in this form, I'm probably just going to use 11 multiplied by 360 divided by 70. And I'm going to probably put that whole term into the formula for the circumference to find the radius. So let's do that. So r is equal to c divided by 2 pi, and in this case c is the x that we calculated here. And you can either use the pi button on your calculator, or you can take 22, or if your calculator does not have a pi button, you can take 22 divided by 7 as pi. So let's do that. So we have this whole thing, 11 multiplied by 360 divided by 70, or you could just use 56.571. That would be fine, since at the end we only need to give our answer to one decimal place. So all of this divided by 2 pi. And for the radius, what I get when I put that in is 9.0036. So what's our next step? And this again was step 2. So step 3 is using the value that we have for R to calculate C. And if you remember, Pythagoras' theorem is a squared is equal to b squared plus c squared. So in this case, this chord, or the length of the chord, is our A, and the B and the C are both R, the radius. So 3 is a step where we're using Pythagoras' theorem. A squared is equal to b squared plus c squared, and we'll substitute in our values. So we're trying to find C, the chord. I'll probably call that CH since we had another C for circumference. So CH squared is equal to R squared plus R squared, which is the same as 2R squared, which is the same as 2 multiplied by 9.0036 squared. CH squared is equal to 162.13. And so that means that CH, or the length of the chord, is the square root of 1.62.13, which is 12.7 to 1 decimal place.